Hey everyone, it's Jacob from Master Camp. Today we're going back to deep space to look at some of the largest structures in the galaxy, stellar nurseries, the birthplace of stars. The life of every star begins with gravity pulling together cold hydrogen gas from the dark depths of space. In between all the stars, our galaxy is filled with 5 to 10 billion solar masses worth of gas and dust, called the interstellar medium. Stellar nurseries form when large stretches of this medium begin to collapse gravitationally into what we call giant molecular clouds, which can stretch up to hundreds of light years across. As they come together, they become dense enough to reflect and absorb neighboring starlight, which allows us to see them through a telescope. These large clouds take on surreal and otherworldly shapes as material begins to further collapse within them, forming small structures like Bach globules, or larger structures like cold molecular pillars, sometimes called elephant trunks. Within these structures, material heats up and begins to spin as it collapses, eventually forming baby star systems called proplyds, inside which planets form in orbit around a hot globe in the center, where a star is being born. A star comes to life when temperatures and pressures rise sufficiently high in the core to ignite nuclear fusion, where atoms smash and fuse together to make heavier elements, producing an enormous amount of energy in the form of light. This high-energy starlight shines out on all of the surrounding clouds and ionizes the gas, energizing the gas to produce light of its own. Each different type of element within the nebula glows different patterns of colors. Over time, though, all these forming star systems use up the nebula's gas, and you're eventually just left with a collection of sibling star systems, which is called an open cluster, home to anywhere between dozens to hundreds of young stars, sometimes even over 1,000. As the cluster gets older, the stars eventually go their separate ways as they gravitationally slingshot themselves from the cluster out into empty space, much like where our sun is today. The high-resolution images returned by space telescopes like Hubble have been instrumental in helping us learn not only about star formation in general, but also about how our own sun and solar system took shape billions of years ago. As one of the most active fields of research in astronomy, new discoveries are being made every year, and I can't wait to learn what we find out next.